Okay, good evening. Good evening, everyone. Something a little bit different today. A while ago, I bought these 4 drills, electric drills that you see in front of you, and I kept these 3 because they were very, very nice. And this one over here was a turd, so I just threw that in a drawer. Didn't really worry about it. But I pulled it out a couple of days ago. Don't remember why, but I was trying to use it for something, and it's fully charged, but it doesn't work. It doesn't come on at all. And just looking at the label here, it says 3.6 volts DC, and it has an 18650 at 1300 milliamp hours. And I'm just kind of curious about what's actually inside this. So I just want to take it apart, kind of look what's inside of it, see what's making it work. I don't expect anything really serious in here. Probably not even a circuit board, honestly. Yeah, I'm not really sure. But it was cheap. It's crappy. This one is for sure crappy. These are cheap and nice, but I just want to take this apart. Let's get in there. And ironically, I'm going to use one of my good drills to do it. So, okay, let's see what we got in here. I also want to say that I'm opening this up. I don't plan on fixing this. I may have been tempted to if it was an actual good drill, but yes, this one is a complete turd. Oh, the buttons just fell out. Oh, pieces falling everywhere. Okay, I think that's the trigger that lets it rotate, so it looks more like an actual drill. Okay, so nothing of interest here. Maybe the spring. I'll keep that off to the side. I'll that later. Oh, there is an actual circuit board here. Let's get this all out of the plastic. Rotary, maybe an analog type switch. Not sure what this switch does at all. It is an LA cell. It says 1300 milliamp hours, but no markings on it at all. Nice beefy looking motor. Plenty of delicious jelly. Oh yeah, that's the good stuff right there. No, it's not. Bunch of gears. They're actually not too bad. I'd keep these. Never know when you can use something like this. They're all plastic though. That's something to notice on that. Although it looks like the main gear on the actual shaft of the motor, this one is metal. So I just grab a magnet up here. Is it steel? It is. So this is metal. But all the actual like gear reduction gears, or those aren't reduction, those are going bigger. Those are all just plastic. Take that off to the side. Let's see what we've got in here. I'm gonna turn my soldering iron on and wipe my hands a little bit while that heats up. And it's mostly heated up. Take this off. And this one. This is mostly what I'm interested in. Oh, of course it is going to have a little bit board in here because it's going to have some kind of charge control chip on here. All right, let's put this off to the side. I'll see if I can get a close-up picture of that, and we can look at that in a bit. And then this, it almost looks like they more or less just used a circuit board just so they wouldn't be dead bugging whatever this switch is. It's a very, very firm button press. Very interesting. I was expecting so much less. They actually put stuff in here for this cheap, crappy drill. These screws are all up in the way. Push them all off to the side. Something I would like to do, I want to pull this cell off, and I have a battery tester charger. So I think I'm going to throw this in the tester and see if it is the capacity it says it is. Actually, one thing I will do before that, there we go, is let's just see if this is actually charged. Because it was on my charger for about an hour, so I expect it to have some kind of charge. But let's see what it's sitting at. Get my multimeter so you all can see this. Make sure I'm in shot. Okay. You do it like this, and then like this. Am I on there? It doesn't look like I was on there. Oh, it's less than a volt. Interesting. So it makes me wonder, did the cell just go bad? It feels very light. But yes, let's go ahead. I'm going to throw this on my charger and see what the test actually says it is, as well as maybe get the internal resistance of this. Can you try it on here and see what happens? See what it says. It's very awkward to hold. There we go. Measuring very little, very low resistance. So, okay. Yeah, I'm gonna go ahead and throw this on the tester. I'll let it run overnight, and we'll see what the capacity of this cell is. In the meantime, see if we get a close-up down on this board. There's only one chip on there. Looks like 2, 3, 4, 5 resistors and a single capacitor. And then, of course, the micro USB input and an LED. So let's go ahead and get this zoomed in. See if we can see what that chip is. Maybe to pull up the data sheet. Alright, now that we've got this kind of isolated by itself, just want to give this a quick look over. There's not a lot of stuff on here. You kind of see this chip. Looks like 55B E, or is it OE? I think it's 55BE. And let's see, let's take a look here. Oops. Looks like the right pin on the micro USB is power, because this left pin goes to this track here, which also connects to the connector. So this is ground. And also go down here, it says negative, LED negative. So power in, looks like 1R0, so two 1 ohm resistors in parallel, so that's roughly half an ohm. Then it goes to this 202, so a 2K resistor here. It also goes over to this pad right here on the LED. That's probably positive. They're both isolated on the back. So one power connector coming in goes to one leg, 2K resistor to the other leg, and it looks like through another 202 resistor, so another 2K resistor to this chip down here, bottom left. And it looks like a two. I'm sure I'll go and read this one. One sec. It looks like another 2K resistor. Yeah, 202 from this track through to this pin here. And it also goes through up here under the bottom. So this is negative. This center pin right here is negative. It goes through to this track. So this is probably a programming pin that sets the current. I want to say this is probably the output. So this is power in, ground, power output, positive, and this one's probably negative. Look on the back. These two tracks here, or these two vias here, in up through here. It goes back over this. Where is this one coming in? This is just negative from earlier, right? Yes. So negative. This is positive. And maybe this track is the voltage in. Well, it looks very, very, very simple. Let's see if we can find a data sheet for this chip. 55BE. So let's over to computer. Let's see if we can find something on this. Alright, back on the computer. I did some digging around looking for this chip. I couldn't find anything that said 55BE. So I started searching 55B integrated circuit, and it looks like this looks like the chip, the 5-pin chip. Starts at 55B with a lowercase b. So I'm thinking maybe that fourth letter is some kind of special identifier. I'm not really sure what. But if we see it, it shows up as TP4055 and 4054. And if you're in any electronics at all, lithium batteries or anything like that, you might have seen the TP4056 chip that's available on the web that's used for as a linear regulator to charge batteries, lithium cells. So I'm wondering if this is just like some kind of predecessor, or it's, I don't know, some smaller SMD style charging chip like the TP4056. Went looking for it, eventually found this page. Again, battery charge IC, so it must be some kind of TP4056 or I don't know, something that came before it. But I finally found the data sheet. It is a standalone linear lithium-ion battery charger with thermal regulation. So it makes sense of what it is being inside the circuit board and there being one lithium battery in there, lithium cell in there. Just started looking at some of the features. It basically looks exactly like a TP4056, except in a smaller package, and it doesn't charge the current as much as a 4056 will. So, keep scrolling down, we can see the pinout on it. Pin 1, the charge pin, pin 2, ground, pin 3 goes to the battery, 4 is VCC in, and 5 is the program. Program is going to set the amount of current that it actually charges to, and looking at their diagram over here, it looks like they're using a 1.6K resistor, and that gives it 500 milliohms. I think they're using a 2K resistor in this board. Just pulling it up and look at it now just to double check. 202, yeah, so a 2K resistor in this board. So I'm wondering if higher current resistor means higher current to charge. I mean resistor. Higher resistor value means higher current to charge, or does it mean slower current to charge? I'm not sure. But I was a little bit mixed up. I thought
pin 1 was VCC in, but that's not quite it. It was pin 4 over here, which following the tracks, I do see where it jumps through the back up here to pin 4. So, yeah, I guess that makes sense because there's also that big capacitor that went between pin number 4 and it looks like the track goes underneath. Yeah, so that yeah, the capacitor right next to it. That makes sense. Just look down here, you can start to see some of the characteristics of it. What's interesting about this is the 4056, the slightly larger version of this, can only work between, it's like 4 point, I want to say like 4.4 all the way up to like 5.4. But this one, you can see, it says it works up to 9 volts for the input. That's kind of interesting, is a higher voltage tolerance. But really, if you give it 9 volts, it's going to burn off that extra voltage in order to get down to the 4.2 that it's charging the cell to. Then we look down here too. The voltage charge is 4.158 at a minimum, 4.2 typically, and then 4.242 at the absolute maximum, which is fine because I think lithium-ion cells actually can charge up to, I think it's like 4.25 volts, or like I think it's close to 4.3. Everyone just goes to 4.2 to give that slight tolerance, safety, because lithium batteries, they could blow up, be dangerous, etc. But I think somewhere in here, yeah, so it talks about the current. So it does look like higher current is slower, or higher resistance is slower charge. As we look at a 10K resistor on the program chip, it's minimum of 90 milliamps, I'm guessing, typically 100, max 110. But if you look at the 1.6K resistor they use up at the top, their diagram, minimum 480 milliamps, typically 500 milliamps, but a maximum 520. So it looks like the lower the current, or lower the resistor, the faster the cell would charge. So that's interesting to see too. And here's just some more typical applications of how they would do it. 1.6K resistor, 1.6K resistor, pretty much the same thing. It follows along this diagram pretty well too. Uh, the one that was in the drill. It looks like it's doing about the same thing. I think they didn't go with the 1 microfarad capacitor on the inputs, but they do have a 10 microfarad capacitor on the output. So pretty typical circuit. If you were looking at TV4056, maybe one day I'll pull one out because I use them pretty often for different kind of projects that I use. Um, but yeah, pretty much it on this one. Interesting board. It's a small amount of components in order to make something to work.
All right, back on the bench, and just to finish it up here, I didn't really do anything with this board right here. I'm guessing this is just some kind of potentiometer that works by pushing down instead of turning. Not too concerned. A diode across the battery, I'm guessing. I just wanted to finish up. Finish testing this. Was a bit confused on the first test because the capacitance was so low. So I ran it again, and I'm guessing this was the issue. So if you look here, first time I tested it, 5 milliamp hours. So definitely telling me it's bad. Tested it again, and it shows it 4 milliamp hours. So this looks like what the issue was. It wasn't the charging board here. Interesting opening this up though and seeing what this looks like. I might save this, just this little PCB right here. It is interesting, and maybe one day I'll need an application where I pull this chip off this board, because this is a pretty substantially large board considering how small this chip is. But I think that's gonna wrap it up. I've got a nice little motor here. Looks like it says 3.6 volt DC RS380. I'm not really sure. Looks like a nice, powerful DC motor. But keep this. I'll probably keep the gearbox and all the gears that go with it, and the delicious jelly. I'll eat some of that later. No, I won't. That's disgusting. I'll keep that. Maybe I'll find a use for something like this in the future, as well as this circuit board. I don't really know why I would need a potentiometer that works by pushing it down yet, but yeah, I'll keep it anyways. that's going to wrap it up with this video. Hopefully it's much shorter than my previous ones. Stick around, stay tuned. Maybe I've got some more interesting stuff coming up. I've got a lot of projects I'm going to work on, and I'll keep you guys in the loop. Take care. Have a great rest of your day.